This is CPM Precalculus Chapter 3, number 112. Using triangle ABC to the right, complete the following problems. So A says find the exact length of AB. AB in the triangle is the hypotenuse. In terms of n, means use these sides to help you. Okay, so AB is the hypotenuse of this triangle, and interestingly enough, it's a right triangle, right? And also these two sides are equal, so it's also an isosceles triangle. It's an isosceles right triangle, which also tells us it's a 45, 45, 90 degree triangle. Anyway, we can do this in a few different ways. I like to use the Pythagorean theorem. Pythagorean theorem tells us c squared is equal to a squared plus b squared, where c is the length of the hypotenuse, or AB, right? Side AB. So let's go ahead and do that. Let's go ahead and call this, well, AB squared is equal to a squared, which is one of these sides, n squared root of 2 squared plus n squared root of 2 squared. Okay? So we can go ahead and say then AB is equal to the square root. If we square root both sides, right, then we get AB left over. Let me do that a little neater. Going up here. And then n times square root of 2 squared is equal to n squared times square root of 2 squared is 2. So it's equal to n squared times 2. N squared times 2, or 2n squared. Likewise, n squared root of 2 squared is equal to 2n squared. Okay, we add those together, we get square root of 4n squared. Now we can square root that, and that's equal to 2n. Okay, so side AB is equal to 2n. Let's go ahead and continue. In terms of n, find sine of A. So here's angle A right here. Sine, remember, from SOHCAHTOA. Right, there's OH, AH, OA. O is opposite side, because we're looking at sine, so we want to look at this one. Sine is opposite over hypotenuse. So sine of angle A is opposite side, so remember the opposite side is where it opens up to this side, which is, so sine of A is equal to this side here, n square root of 2 divided by h, which is the hypotenuse, 2n. Simplify this, the n's go away, you get square root of 2 over 2. Okay? Part C says if n is equal to 12, what is the value of sine A? Sine of A is equal to, well, it doesn't matter what n is, right? N cancels out, so it's still equal to square root of 2 over 2. No matter what n is, n could be anything. Well, I don't want to cross it out, I just want to say it doesn't matter here, right? N doesn't matter. If n was 10,000, sine of angle A is still square root of 2 over 2. What does this tell you about sine of 45 degrees? Well, this tells you sine of 45 degrees. We know A is equal to 45 degrees, remember. Sine of 45 degrees is sine of A is always square root of 2 over 2. No matter how big that triangle is, if we have a 45 degree right triangle, right, if we have a 45, 45, 90 degree triangle, sine of 45 degrees is always going to be square root of 2 over 2. So I'm going to write sine of 45 degrees equals square root of 2 over 2, always. Okay, always true. In fact, if you were to pull out your calculator, turn it on, change the mode to degrees, which it is in mine, and do sine of 45 degrees, you would get square root of 2 over 2. How do I know that is square root of 2 over 2? Well, I can go ahead and type in square root of 2 divided by 2, and voila, they're equivalent. Okay? What about cosine of 45 degrees? Well, cosine of 45 degrees, well, since our angle A is 45, I can use angle A, and cosine, remember, is A over H, which is adjacent over hypotenuse, which is square root of A, or it's n times square root of 2 over 2n, is equal to adjacent over hypotenuse, which in this case is n square root of 2 over 2n. The n's cancel out again. We're left with square root of 2 over 2. So no matter what n is, cosine of 45 degrees is also equal to square root of 2 over 2 always. Okay, so we just figured out how to find the value of cosine of 45 degrees and what it is always, because we know how to look at a 45, 45, 90 degree triangle, and we could take the sine of a side, right? We could just make this anything, find the third side using the Pythagorean theorem, and voila, square root of 2 over 2 always. That ends CPM Precalculus Chapter 3, number 112.